morning students. Today my lecture topic is on buses and ports. Basically this topic is related to personal computer organization, and it is a, you can say, a part of motherboards, and it is related with interfaces and communication paths. So first of all we will discuss what is a bus. So bus connects the part of CPU to each other. It links CPU to various components on the system board. Basically you can say bus is just like a communication path between the various components on the motherboard. It connects your processor chip to various input output devices and memory part. So we can say it is a pathway for bits representing data and the instructions. So second very important thing in bus is bus width. It depends on the number of bits that can travel simultaneously down a bus is known as a bus width, means number of bits it can carry. It specifies the bus width. So next is the categories of the buses. First we have system buses and expansion buses. System buses connects your processor chip to memory parts on the motherboard, and expansion buses connect CPU to the slots on your system boards. So system buses connects your processor to the memory devices, and expansion buses connects your processor chip to the slots on the motherboard. This is the block diagram where we are showing that here is your processor chip CPU, which is connected to the memory by using system bus, and your processor is connected with hard disk drives, keyboard and mouse with IO buses by using use of IO buses. And here also on your motherboard we have two types of bridges which provides the communication. First is the south bridge and north bridge. Then IO buses and interfaces. There are many standards for IO buses and interfaces. Standard basically allows open architectures. Many vendors can provide peripheral IO devices for many different systems. Most systems support several IO buses and IO interfaces. These are the examples of the IO interfaces and buses. First we have expansion buses or slots on the motherboard. Then second is disk interfaces, third is external buses, and last part is communication interfaces. So these are the various buses and interfaces slots on your motherboard. So first we will discuss expansion buses. These are the slots on your motherboard, and we have various types of expansion buses like ISA, PCI, EISA, SIMM, DIMM, MCA, AGP, VESA, PCM, CIA. ISA is the basically older version of the slots available in previous your old versions of motherboards. The full form of ISA is industry standard architecture. Then we have PCI slots, personal computer interconnect. EISA, this is the extended version of ISA slots. Then we have SIMM slots and DIMM slots. These are two slots for memory. The full form of SIMM is single inline memory module, and DIMM is dual inline memory module. MCA is micro channel architecture. AGP is accelerated graphics port, and VESA is Video Electronic Standards Association. PCM CIA is Personal Computer Memory Card International Association. So these are the various full forms of the expansion buses. Later on we will discuss the various features of these buses. So here is the diagram. Basically it is a motherboard on which we are showing various slots. So first is your 3 ISA slots. On your motherboard you have 3 industry standard architecture slots. Second, you have 5 PCI slots. PCI means peripheral component interconnect slots. Then next you have Pentium CPU socket on which you are placing your processor chip. Then you have 6 SIMM slots, means single inline memory module slots, and 2 dual inline memory module slots. So, these are the various slots. This is a just physical representation on your motherboard, that how they are look like and where they are placed. So, all these are your expansion buses. Second part is disk interfaces. In disk interfaces, you have ATA, IDE, EIDE, floppy disk, SCSI, ESTI, and PCMCIE. ATA is AT attachment, named after IBM PC AT. IDE is integrated drive electronics. It works as same as your ATA, and EIDE is enhanced integrated drive electronics. These are used to connect your CD-ROMs with your motherboard. Then you have floppy disk drive. SCSI is small computer system interface. ESDI is enhanced small device interface. It is introduced in mid 80s, but right now it is totally absolute. So, last is PCMCIA. So, these are various disk interfaces for your hard disk drives, CD-ROMs, and floppy disk drives. Then third part which we will discuss is the external buses. In external buses, you have various examples like parallel buses, serial buses, PS by 2, USB, IRDA, and Firewire. Parallel buses, sometimes called LPT. LPT port is basically COM port and LPT ports. These are used in terms of DOS. So, LPT is line printer slot, and serial, it is typically RS232C standard, which we named as a serial port. It is basically an interface for serial communication. Then you have PS by 2 for keyboards and mice. Then USB, USB is universal serial bus. IRDA is infrared device attachment. Firewire is new and very high speed, dwelled by IEEE standard. Here one term which we will discuss, that is the hot swappable devices. Unlike your USB is a hot swappable port. Hot swappable means while your PC is working, you can attach any device for processing and you can remove. Like in USB ports, you can anytime while your PC is on, you can attach pen drive for data transfer without shutting down your PC. So, these feature of USB port is very important and very useful nowadays. So, it is a hot swappable port. Then the last is communication buses. It is used for connecting systems to systems. In this we have parallel LPT ports, special purposes, for example using special software to transfer data between the systems. Then you have serial and RS232C to connect a system to voice grade modems. And last is Ethernet to connect a system to high speed network. So, these are the various communication buses used in the personal computers. Now, we will discuss processor bus. The communication pathway between the CPU and immediate support chips. The processor bus is basically, you can say, it is a communication path between your CPU and any intermediate supporting chips, and it is used to transfer the data. What are the two devices between where the data exchanges take place? That is between CPU and the main system bus. Second is between CPU and external memory cache. The purpose of processor bus is to get information to and from CPU at the fastest possible speed, and it is tied to the external processor pin connections. So, basically we can say processor, the main function of processor bus is it is a communication path between CPU and intermediate supporting chips. Second, It is used where we have to access the data at the fastest speed. So, this is the function of the processor bus. Next is memory bus. Memory bus is used to transfer information between the CPU and main memory. In memory bus, there is a transference of information between CPU and the main memory system, you can say RAM in the system, as a dedicated chipset that is responsible for the transferring information between the processor bus and the memory bus. The information that travels over memory bus is transferred at a much slower rate than the information on the processor bus. Means if we say the differences between the processor bus and memory bus is that processor bus is used to access the data from the CPU as the fastest rate. But as we compare memory bus with the processor bus, we will find that the speed of memory bus is very slower. The size of memory bus, it controls the amount of memory that CPU can address directly. If we want to define the size of memory buses, it is directly related on the address lines of your processor. So, this is the basic differences between your processor buses and memory buses. Your memory buses deals with the processor and main memory. Then you have address bus, a subset of processor and memory buses. It is a, you can say, a portion of the processor and memory buses used to indicate what address in memory, what address on system bus, and indicates precisely where the next bus transfer or memory transfer will occur. So, here we have, in the previous diagram we have seen various slots like PCI slots, ISA slots, then CPU socket, SIMM and DIMM. Now, we are briefly defining the expansions buses and its features one by one. So, first of all, we will take up industry standard architecture bus. Here in the diagram, there are two types of the ISA slot. First is the 16-bit ISA slot and next is 8-bit ISA slot. 8-bit ISA slot is the previous version. Nowadays, we have motherboards with the feature of 16-bit ISA slots. These are the features of the ISA slots, that is 8-bit ISA bus used in original IBM PC computers, and it is also called card and edge connector. An adapter card with 62 contacts on its bottom edge and plugs into a slot of the motherboard that has 62 matching contacts. Provide 8 data lines and 20 addressing lines, enabling the slot to handle 1 megabyte of memory. Then 16-bit ISA bus, it is developed by IBM, introduced in 286 processor in 1984. This processor had a 16-bit data bus, meant that the communications between processor and the motherboard as well as memory would now be on 16-bit wide. In 8-bit wide ISA slot, we have seen that in that case only 8-bit of data can transfer. But in case of 16-bit ISA slot, we can communicate with 16-bit wide of data. The introduction of 286 chip posed a problem. Then IBM opted for the later solution. PC80 was introduced with the set of expansion slots with 16-bit extension connectors. So, these all the features of 16-bit ISA bus. Further, we also having more features. This is about the 32-bit ISA bus. After 32-bit CPUs became available, it was some time before 32-bit bus standards became available. Then industry standard architecture history is that originally introduced in IBM PC in 1981 with 8-bit expansion slot, and it runs at 8.3 megahertz of frequency with data rate of 7.9 megabytes per second. This is the feature of 8-bit ISA slot. Now we have 16-bit version introduced in IBM PC80, runs at 15.9 megahertz with data rate of 15.9 megabytes per second. So as from these features you can see that 16-bit version of ISA slot is more appropriate and accurate, and it is reliable for the use in the motherboard. Sometimes it is also called AT bus. Today all ISA slots are 16-bit. Configuration parallel or multi-drop. It can be we can use this in the form of parallel or multi-drop. Further, it is used just about any peripheral like sound cards, disk drives, etc. One more feature in ISA is PNP ISA slot. In 1993, Intel and Microsoft introduced PNP ISA for plug and play ISA, allows the operating system to configure expansion boards automatically. This is the plug and play ISA feature. Then form factor, large connector in 2 segments. Smaller segment is the 8-bit interface, means 36 signals. Larger segment is for the 16-bit expansion, that is 62 signals, and 8-bit cards only used for the smallest segment. This is the advancement of ISA slots. In the advancement of ISA slots, we have EISA MCA. EISA is extended ISA slot designed by 9 IBM competitors and intended to compete with IBM MCA. EISA is a hardware compatible with ISA. Then MCA is micro channel architecture introduced by IBM in 1987 as a replacement for the ATN ISA bus. But both these EISA and MCA have not been successful. These are the micro channel architecture MCA bus. This is the features of micro channel architecture bus. The introduction of 32-bit chips meant that ISA bus could not handle the power of another new generation of CPUs. IBM decided to build a new bus, and the result was MCA bus. Then MCA runs asynchronously with the main processor, meaning that fewer possibilities exist for the timing problem among adapter cards plugged into the bus. An MCA system has no jumpers and switches. Through implementing bus mastering, the MCA bus provides significant performance improvements of older ISA buses. Means if we see the differences between ISA slots and MCA slots, that is that MCA slots has significant feature of bus mastering, that each device is given a priority code to ensure that order is preserved within the system. So we have 4 types of slots: MCA slots, 16-bit, 16-bit with video extensions, 16-bit with memory matched extensions, and 32-bit. Then you have EISA bus. It was announced in September 1988 as a response to IBM's introduction of MCA bus. Then developed primarily by Compaq, taking over the future development of PC bus away from IBM, gave the design away to other leading manufacturers, formed the EISA committee, a non-profit organization designed specifically to control the development of EISA bus. These are the features: provide 32-bit slots, enables manufacturers to design adapter cards that have many of the capabilities MCA adapters, support adapter cards created for the older ISA standard, permits greater system expansion with fewer adapter conflicts. These are the EISA bus, and here we have EISA slots. So in the diagram, these are various EISA buses. Now add 90 new connections without increasing the physical connector size of 16-bit ISA bus. The EISA adapter however has two rows of connectors. First row is same kind just used in 16-bit ISA card, and other is thinner row extends from 16-bit connectors. In the diagram we have seen there are two rows, right. So, here we are discussing that first row is same as 16-bit ISA card, and another other is thinner row extends from 16-bit connectors. This is VESA local bus. In the diagram, VESA is Video Electronic Standards Association local bus, the most popular local bus design from its debut in the August 1992 through 1994. It was created by the VESA committee, a non-profit organization founded by NEC, to further develop video display and bus standards. Offers direct access to system memory at the speed of the processor itself. Can move data 32 bits at a time, enabling data to flow between CPU and compatible video subsystem or hard drive at a full 32-bit data width of 486 chip. Now, there are some limitations of VESA. The first one is dependence on 486 CPU, means it is tied with 486 processor bus. This bus is quite different from that used in Pentium processors. Second limitation is of speed limitations. Provides for the speed of up to 66 megahertz on the bus. In practice, running with VL bus at the speed of 33 megahertz causes many problems. Second is the electrical limitation, has very tight timing rules and designed for limited loading on the bus. Third is the card limitation, the number of VL bus cards is limited. So, these are the four limitations which are existing in your VESA standards. First is on dependence on 486 CPU, second speed limitation, third electrical limitation, fourth card limitation. Now, next type of buses, up till now we have discussed ISA, EISA, MCA, and the previous one is VESA. So, we up till now we have discussed the features of all these expansion buses. The next we will take up peripheral component interconnect bus. As shown in the diagram, it is the slots which are varying from 5 to 6. Now, peripheral component interconnect bus. The PCI bus specification released by Intel in June 1992 and updated in April 1993, redesigned with the traditional PC bus by inserting another bus between CPU and the native IO bus by means of bridges. As we have discussed earlier also, on your motherboard you have various bridges also, north bridge and south bridge. Basically, north bridge connects the components which are slower in speed, and south bridge connects the component which are transferring data at the very high speed. So, we are inserting these slots for improving the performance of the further improving the performance in the communication on the motherboard. It adds another layer to the traditional bus configuration, uses system bus to increase the bus clock speed. The introduction of PCI slots with ISA slots or EISA slot is just that the speed of PCI slots are very high or very fast as compare when we are comparing this with ISA slot. So, it is a local bus. History, it is developed by Intel, very successful and widely used, much faster than ISA and gradually replacing ISA. Means nowadays where we have concept of minimization, over there sometimes it can replace your ISA slots also. So, we are according to our form factor we can minimize our size of motherboard also. Configuration as same as parallel in multi-draw form, then it is used just about any peripheral and can support multiple high performance devices. Graphics, full motion videos, SCSI, local area networks, etc. And specifications of PCI slots are 16-bit bus compatibility, usually implemented as a 32-bit bus and runs at 33, where in the earlier ISS slots we have discussed in 16-bit ISS slot the maximum speed is 15.9 megahertz, but in case of PCI we are having speed of 33 megahertz or 66 megahertz. At 33 megahertz we have 32-bit bus and data rate is 133 megabytes per second, which is quite very high as we compared with ISS slots. Then the third is AGP, accelerated graphic port. First appeared on Pentium 2 boards and dwelled just for graphics, especially 3D graphics. At this AGP port is provided for graphics, and as we have seen that it is used widely for 3D, three-dimensional graphics. Configuration is same, parallel and point to point. Specification that data rate is up to 532 megabytes per second, which is again 4 times of PCI. So if we compare ISS slots, PCI slots and AGP, so we can say AGP is the very fastest, its speed is very fast, just like we can say it is 4 times of PCI. So this is how we identify ISA, PCI and AGP slots on motherboard. First is AGP slot, second is PCI and last is ISA slots. Now we have serial interfaces. On PCs, a serial interface implies a COM port or communication port. COM port 1, COM port 2, COM port 3. Basically, these are for communication, and if we say COM port, it is used in terms of DOS. So COM ports conform to the RS-232 interface standard. So now we will discuss about the RS-232 standard. History: well established standard developed by EIA, Electronics Industry Association in 1960s, originally intended as an electrical specification to connect computer terminals to modem, then defines the interface between a DTE and a TCE. It is just a serial communication interface, RS-232. So when we are talking about communication, we have two types of devices. First is DTE and second is DCE. DTE is data terminal equipment, the terminal point, and DCE is data communication equipment, means modem. So a modem is sometimes called a data set, and terminal is anything at the terminus of the connection, which is at the terminal part. So VDT means you can say video display terminal, it can be video display terminal, it can be computer and it can be printer. So this is the traditional configuration of DTE and DCE. Here we have DTE as a computer and DCE as a your telephone, you can say modem. So between DTE and DCE you have RS-232 interface at the both ends, and for connecting two DCE equipments you have telephone network. So this is the importance or serial interface between your DTE and DCE, that is RS-232C standard interface. This is the specification part. Here first we have data rate. The maximum specified data rate is 20 kilobits per second with maximum cable length of 15 meter. However, it is common to push an RS232C interface to higher data rates, and data rates to 1 megabits per second can be achieved, and its configuration, if you say serial, point to point. Before discussing these two modes, synchronous and asynchronous, which are taking place while we are using serial data transmission, the first thing is that asynchronous modes. In asynchronous mode, transmitting and receiving